definitions of proofs, drawing conclusions, identifying triangle apocalypse, and side, triangle side, angle side, and angle side.
Hey, I'm Pat, and I'm going to be telling you some definitions for proofs. First definition is the midpoint of a segment. The midpoint is the point that divides the segment into two congruent segments. The definition we're doing is the bisector of a segment. Alright. There's the segment, and it's going to be bisected, creating two congruent parts.
The bisector of a segment is a line, segment, ray, or plane that intersects a segment at its midpoint.
Third definition I'm going to be doing is a bisector of an angle. Alright. There's the angle. And it's going to be bisected, creating two congruent parts.
The bisector of an angle is the ray that divides the angle into two congruent adjacent angles.
Definition is the reflexive property. When two triangles share the same side, that is an example of reflexive property.
This is an example of the reflexive property because AB equals AB.
The definition I'm going to be doing is the vertical angle definition. Okay. Two triangles, and angles 1 and 2 are vertical angles.
Vertical angles are either of two equal and opposite angles formed by the intersection of two straight lines,
creating two congruent angles right here. The definition I'm going to be doing is the definition of perpendicular lines. If line AB is perpendicular to BC, then it will create a right angle.
The definition for perpendicular lines is two lines that intersect to form right angles.
Hey, I'm Jake, and we are going to be drawing conclusions.
For this problem, one conclusion you can make is that C is the midpoint because the given is AC equals CB.
Given is BD is a median, and the conclusion is AD is congruent to CD.
The given is CD is perpendicular to AB, and the conclusion we can make for this is angle CDB is 90 degrees. The given is BD bisects angle ABD, and the conclusion we can make for this is angle ABD is congruent to angle CBD. This problem, the given is two intersecting segments, and the conclusion we can make for this is angles 1, angles 2, angles 3, and angles 4 are all vertical angles. Problem, the given is triangle ABC is isosceles with the base AC. A conclusion we can make for this is that segment AB is congruent to segment CB.
Yeah.
Problem, the given is BD bisects AC. And a conclusion we can make for this is that AD is equal to DC.
Yes.
Problem, the given is angle 1 and angle 2 are right angles. A conclusion we can make for this is angle 1 and angle 2 are equal to 90. Their lines form 90-degree angles. This problem, the given is PR is the altitude of AT in triangle PAT. The conclusion is PRA is 90 degrees, and the reason is altitudes form 90-degree angles.
90-degree angle.
The given is BD bisects angle ABC. A conclusion we can make for this is that angle ABD is equal to angle CBD. The reason is that bisectors cut angles in half. We'll be identifying the triangular apocalypse. For these two triangles, it is not possible that they are congruent because or to prove that they are congruent, because you only have two equal sides.
Yes.
For these two triangles, you can prove them congruent by side, 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 because they have three congruent sides.
S, S, S.
Triangles, you can prove them congruent by side, side angle, because they have two congruent sides and then one congruent angle. Triangles, you can prove them congruent by side, angle, side, because they have two congruent sides and then the angle in the middle. SAS. For this problem, it can be proved congruent by side, angle, side, because of the reflexive in the middle, and then the congruent side, and then congruent angle.
SAS.
SAS.
SAS. SAS. SAS. For this problem, the two triangles can be proved congruent by ASA, because of the angle right here, the reflexive sharing two sides, and then the angle on top.
ASA.
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 Triangles can be proved congruent by AAS.
Not do angle, 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 or side, side angle. These are not allowed.
Now we're going to do proofs using the triangle postulates that we just used. And here's the first problem. It's a pretty simple one. The first thing you're going to want to do is mark your diagram for all the congruent sides and congruent angles. When there's more than one congruent side, you do 2 dashes instead of 1 for the first one. And then first thing you do is you write out the given, and this problem is very simple, so that's all there is to it. And then you just state what you want to prove. And for this problem, it's a side angle side problem, and that's really all there is to it for this one. And now on to the second problem. This one is a little bit more complex than the last one, and you're going to start out the same way you did. So you're going to want to mark your diagram, and for this, also the same thing, like the sides, you need to make 2 different marks for the congruent angles, so you don't mix those up. And one thing I like to do on these problems is, if you can tell what you're going to be proving it by, is you mark that postulate on the side and cross off each one when you know you have it. So, for example, I would put AAS, and as I went along, I would cross off each one. And then once I cross them all out, then I know I proved it correctly. And also for this, you're going to want to prove this by angle, angle, side. And the second thing you need to do is mark the reflexive property. Also in the diagram, when you do that, you put an X on the diagram where they share the sides. And there it is. Now on to the next problem. Again, first thing you want to do is mark your diagram. So angle A is congruent to angle E, and angle CBA is congruent to angle CBE. And then it says B is the midpoint of AE, so you would mark that with 1 dash mark on either side of B. Okay, so then you state the given. And then the next thing you want to do is say that AB is congruent to EB. Okay, and then the reason you say for that is midpoint cuts segments into two congruent parts. Like that. And then, again, you state what you are proving. So, ABC is congruent to triangle EBD. And the reason for that is angle, side, angle. And that's it. Okay, now for another problem. This one's going to be side, side, side. And again, you're going to want to mark your diagram. So, it says here BA is congruent to DC. And then, that's all it is. That's all we can mark in the given so far. So, now for this, you say that since BD bisects AC, that would mean that AE and CE are congruent. So, write that down. And the reasoning would be bisectors create two congruent parts. And the next one, AC bisects BD, you can put that under the same reasoning. So that would mean that BE is congruent to DE. And then you would want to mark that on your diagram. So just like that. And then you have all three sides. So you'd want to cross it out right there. And then you would state what you want to prove, which is triangle ABE is congruent to triangle CDE, and it is congruent by side, side, side.